Okay, so that's what we're going to look at here are percentages. Okay, now what does a percent mean? Wait, did I? Yes, recording. Okay. Now, what does a percent mean? Well, basically, when they say percent, they mean per 100. That's really what they're trying to say here. It's per 100. You know, you see this happens like all the time in the world around us. You know, 10% of the people did this, or 20% of the people on campus, you know, have done that, you know, that kind of thing. But what do they really mean? They mean per 100. You know, when you have B% for some number B, they're really saying this. B over 100. As a decimal, you would have this. I know this looks kind of funny, this notation, but, you know, it's just a decimal. B could be like a number, like 10, 1, 4, whatever. And that's what I'm trying to say here as well. Notice from here, you can actually convert between, as I do down here, fractions and percentages. Something like 1 over 5 is the same as 20% because you just convert that to a decimal. That's what we're doing there. Or if you take something like 98%, you get 0.98. I'm just trying to introduce you guys to percentages, so that kind of thing. Okay. And now percentages do have a connection with proportions, and that's actually what we can get to next. Something like this. Well, I guess, yeah, it has to do with, I don't know if it's, well, it could have to do with percentages, but basically the top line here tells you how to deal with percents. You could think about part over whole. A percent is part over whole. That's really what you want here. Actually, you know what? Let me underline that. That might help. Okay, like this. And that's really an equation that's good to know. Percent is part over whole. Okay. And just remember also, when you do this, you want to write percent as a decimal. So for instance, as in this example, suppose you have a tax on a sales tax, excuse me, is about 12.1%. You know, how much you're actually going to pay depends on how much you purchase, that is, how much tax you pay. It's 12.1% of how much you purchase. So if you spent $100, that's telling you the whole is our purchase, you know, the entire amount. Tax is a part of the purchase. In other words, you have this. So whole is our purchase, and tax is part of it. So our tax then would be percent over 100 times our purchase. Okay. Tax is part, purchase is whole. So basically, I didn't show it, but I substituted here, and percent I converted to a decimal. Okay. All right. And then also, if you have $25 instead, it's the same idea. So. I didn't think we'd get this far, so bear with me, to be honest. I mean, I didn't think we'd get this far. I thought the other stuff would take longer, so bear with me. Okay. But again, it's just percentages, though, that's all. When you have percent here, if you want to convert it to, you know, a decimal, you just divide by 100. That's what I'm doing over here. Okay. Okay. If you want to convert this to a decimal, you can move it 2 spaces to the left. All right. Let me move on. And these are just other examples here. So, you know, percents do come up in a lot of places. I'm just trying to get you to understand percent. 35% of all the people in town said they would vote for some person, John Doe. I made that name up. Okay. Now, how many people are actually going to vote? Well, it depends on how many people there are in town. So if you have, let's say, yeah. So if you have, let's say, 1,100 people in town, you could calculate how many people are going to vote for John Doe. I mean, in this case, the people that are going to vote for him, that's your part. I'm basically telling you that the people in town that's your whole, so to say. Okay. So 35% of all the people. of all the people. So that's what we're doing here. So the people that will vote for John Doe, that would be the part. Okay, and that's what we're looking for. And the number of people in town would be whole, 35% of all the people. Okay. Okay. Good. So that's what we have here. And then when you do the calculation, you have this. So again, notice I did convert it to a decimal. Basically, I wanted to take the percent sign away. So 0.35 is part over whole. And now I'm just solving for part. And we get 385 people. Okay. Good. All right. Good. Okay. That's what we have here. But now notice if you look in B, what I'm saying here is, I'm actually saying that, let's suppose now that 1,100 people, those are the ones who said they would vote for him. So I'm telling you that, so basically what I'm telling you is that 35% of the town people equals 1,100. So I'm basically telling you what part is. We have to figure out what whole is. But that's easy though, right? That's just from this. So you just have to cross multiply. Okay. So that's what you're going to have to do. I mean, that's really what it boils down to. So. Okay. Good.
You just have to cross multiply for the other thing too?
You can. Let me just see. I think you can, but oh yeah, you do. I'm sorry. Yeah, but it's just that in the other one, part was the unknown. Here, whole is. In fact, as you can see here, whole is the unknown. So I'm just showing you like how to calculate it. So you do cross multiply in both cases. So, I didn't think we got this far. So this part, I didn't practice on my own. So bear with me. So, okay. I hope that makes sense what I'm doing.
And why wouldn't it be the same answer if you're just cross multiplying in both cases?
Because in the other case, part was unknown, as you over here.
Yeah.
So part would basically take the role of a 1,100, and whole is the unknown here, the denominator. I hope that helps.
Yeah.
Okay, kind of, yeah. All right. But that's what's happening here, though, so. Okay, so basically that's what's happening here. So this is what we get, as you can see. Okay. Okay, and again, this is actually how you figure out what whole is, so. Okay. So this is what we get. And by solving for it, we end up getting there's about 3,143 people in the town. So here I'm telling you how many people equals that 35%. But 35% of what? Well, that of what is what we're finding. So, okay, good. All right. Now, okay, that's really the idea with percents. Again, let me just go back. Yeah, let me go back. And it really just boils down to doing this, though. Sometimes with like of, you can figure out like which is your part, which is the whole, that kind of thing. So, okay, do a little bit more. All right. Okay. So we have that. Okay. All right. Okay. Now, related to that, building on this, we have these two concepts of, here it is, absolute change and relative change of something. These are just two formulas here. And absolute change is just, you have two quantities and it's given by the formula. You have the ending minus the starting. For relative, you actually do, excuse me, you will actually get some kind of a, how do I say it? Since you're dividing, you could convert this into a percent. You just have to multiply by 100. Okay. And this is something that comes up also. Sometimes in absolute change, you will subtract or add percentages. And when you do that, though, your units, it's going to be kind of weird, but the units are called percentage points. Okay, let me do one more example. Okay. So that's what happens here. So let me just do an example of this. I think we might end early today. Okay, so let's say 1 week I decide to run, 25 miles. Okay. And then the next week I ran this amount. So basically here, what we can do is get absolute change and percent change. And absolute change is actually pretty easy. You just subtract the ending to starting, right? I started out running 25 miles per week, right? But then the ending would be 28 miles. Start 25, end in 28. So we subtract, I get 3-mile difference, right? For percent change, I'm converting it to a percent, but you have to know what to divide by, and that's the starting quality. That's what the formula is. So here the percent change was 12%. And notice again, you have to convert it to to convert it to a percent, you want to multiply by 100. Or that is, move the decimal to the right 2 spaces. And then here's another example, as you can see. We have a car, the value of it is dropping from, it starts out, in other words, as this amount, but then it ends up here. You can get the percent change. I mean, basically you just subtract, but here notice you want to get a negative answer because the value decreased. In other words, it started out higher than it ended, so you know the answer is going to be negative, and because of that, percent change will also be negative. Okay. Okay, does that kind of make sense what I'm doing? Because I didn't think we got this far. That's why I think I may have to stop here. So, all right. I think we'll stop here. Well, I'm going to do the stuff next week. I really don't like, I mean, I'll work on this next week with you guys, okay? So we'll end early today.
Okay, thank you.
You're welcome.